Right, welcome everybody. In this video, we're going to go through how to use a TVM calculator, which stands for time value of money. So I've got a Google tab here on the left with a web browser, and on the right, I have loaded up the Desmos Scientific Calculator. We're just going to use that to kind of compare some of the results, at least for some of the earlier uses of the TVM calculator. We're mostly going to focus on the left side of the screen, working through some different scenarios and how it overall works. So to get here, I'm using this top link here. The domain is FN Calculator, and I always get there by Google searching TVM Calculator, and it's usually the first one that comes up. So I'm going to click on it here, and I'll just zoom in a little bit. We're really just focused in on the middle section here, everywhere from the mode where it has end or beginning. We're not going to worry about the advanced version button in the top, but we do want to see the PV, payments, future value, the interest rate, the number of periods, and the compounding periods working here. So these are variables that we've seen before in the compound interest formula and kind of also in some degree with the simple interest formula, except for the mode, the end or the beginning. We'll look at maybe what those differences are when we switch over to kind of investment type problems, because then it kind of makes sense when you'd make that first payment. But how you use this TVM calculator is that you should make sure that you have all of the information except for one of them. For example, if you knew the present value, the payment amount you're making, the future value, and the annual rate, you would be able to use this calculator to calculate the periods. So you would put in your information for present value, payments, future value, and annual rate. Once those are in there, then you would press the periods button on the right side, and it would fill in the last missing blank with the answer. Okay, so we want to use this to make annuity calculations. For the most part, it's like finding this magic payment amount that makes a repayment schedule work. You know, if you want to repay in 24 months, you can use this calculator to figure out exactly how much you need to repay each month. Okay, so, but just to kind of show you how it works, we can also use this for compound interest questions, because those we can check in the calculator, and you can kind of get an idea of how this works. Okay, so if it's a compound interest question, or if it's a lump sum, there are no payments there. So I'm just going to go ahead and make that 0. Okay, that is the main function of an annuity, is that there are recurring and consistent payments. So if we set the payments to 0, there's no payments, then we're just dealing with a lump sum, gaining interest, or something like that. So we could do a question like, let's say the interest rate was 4.5%, and then we're going to say this is compounded monthly. So there's monthly. And let's do this for 1 year, which is going to be overall 12 months. So the number of periods is 12. Okay, so we got an annual rate of 4.5%, compounded monthly. So that's how we would enter that information in there. And let's say the present value is $600. So we've now filled out everything except for the future value. So at this point, now I'm going to click future value to get the answer. So $600 invested at 4.5%, compounded monthly for 12 months or 1 year, would be worth $627.56. Okay, so right off the bat, you'll notice that there's a negative sign there. What that kind of means is that this would be money coming out of your pocket. For the most part, we just want to focus on the value and not necessarily the negative sign. But a negative does mean that we would be kind of paying that value back. So how we would read this is that if this $600 present value is positive, that means we kind of borrow that money. That's money coming into our account. So we're borrowing $600, so it's positive, and then we would have to return $627 as a payment. So it's kind of a cash in and cash out situation. But unless you're getting into more complicated problems, you can kind of ignore the negative sign in a lot of these cases. So we're not going to focus too much on it. But if we are using it with, it means that money's coming out of the account. We're making a payment. Okay, so let's do that exact same calculation in the scientific calculator so you can see how they match up. So the formula for this equation would be $600, and then we would times by, in brackets, 1 plus I So I is 4.5%, so 0.045, but it is compounded monthly, so we do have to do this thing where we shrink we subdivide up the 4.5% into an equal amount each month. So we just have to divide by 12. So this is the bracket, and this is raised to the exponent, and it's the number of periods, so that's 12. So when I run through that calculation, you see we get the exact same $627.56. No negative on this when we use the calculator. The negative is inserted as part of the TVM calculation. Okay, so again, don't worry too much about the negative. It's mostly not going to matter that much. So let's just do one more example with a future value calculation, or sorry, maybe we'll do a present value calculation. So I'm going to reset this whole thing here on the left. And let's say we have an interest rate, let's make it 11%, and we'll make this, say, compounded bi-weekly. So that's 26 periods. Oh, whoops, I wrote the 11 in the wrong spot. The 11 should be in the interest rate, and the periods we don't know yet. But this is going to be 11% compounded bi-weekly, and that means 26 periods per year. And let's make this investment last 3 years. So that's going to be 26, 52 periods, and overall 78 is 3 times 26. We're just doing a lump sum, again, just testing out the calculator. So we're going to make the payments 0 for now. And we said we were going to calculate the present value. So let's say at the end of the day, we were going to get back, let's say, $100,000. Okay, so this is a positive value. So we're going to withdraw this. So the present value is actually going to give us a negative answer because we would need money to come out of our account to invest that. That's what the negative sign would mean here. But we've got only one blank left as the PV. So if we press that button next to present value, then it will calculate what we need to invest. Okay, so let's go and see what that is. It says that at 11% compounded bi-weekly for 3 years, we would need to invest $71,942 in order to have $100,000 to return to us in 3 years. So this is a calculation we can again make in the calculator. So let's go ahead and do that. So the future value is the 100,000. So when you rearrange this equation, you basically divide by the 1 plus I to the power of n. So I'm just going to start doing that. So future value divided by this bracketed term, it's 1 plus 11%, so 0.11, but it is bi-weekly, so in the calculator we would need to make sure to divide that by 26 to split that into the correct portion. If you don't, the interest rate is way too high and you'll get a very wrong answer. So when you're doing this in the calculator, you have to be careful to divide up the interest rate per year to get the right interest per period. But with the TVM calculator, it does that for you. You just enter in the annual rate and then you put in, the compounding period. So I'm missing the exponent here, which was 78. So when I calculate that, then we get the exact same $71,942.44. So again, no negative sign on the calculator. That's just something the TVM calculator tends to insert because it's from a business point of view, usually. Okay. All right, so now let's look at a few different situations. We're going to use this to calculate the payment on a loan repayment. Okay, so we're going to work with a question that says we're going to take out a loan. Let's take out a nice even value like 1,000. And we're going to repay this back. So any loan repayment, the future value of that loan should aim to be 0. Okay, right? You don't want any debt left over. So go ahead and make it 0. So we're going to be solving for the payments, so we're going to leave that one blank. That's the one we want to solve for at the end. So we borrow $1,000, and let's give it an interest rate. Let's make it 4%, and let's make it as easy as possible. We'll do 5 years, and we'll say this is compounded annually. Okay, so this, if we were to do this in a scientific calculator, we would need an annuity formula, and those are more complicated and we don't cover them in our course. So we would rely solely on the TVM calculator to get the payment here. But notice that I filled everything in except the payments. And so when I press the payment button, we again get this negative sign. So that means it's money coming out of our account, which makes sense because we're repaying, it's $224.63. So if we wanted to pay back this $1,000 loan that we take 5 years to repay it, and the interest rate is 4%, we would need to pay $224.63 at the end of each year. That will work out like perfectly within a few cents. Okay, there's always a little bit of rounding error when you get to the nearest cent, but that's what this calculator will tell you. Okay, let's do another example of a loan. So it's going to be the payments that we leave blank. Then we'll switch over to the investments. So before we get into here, I'll just make a note about the mode at the top where it's end or beginning. So there is a question of when you make your first payment. Okay, for most loans, it doesn't make sense to repay like right at the beginning. That's what this would mean. If you switch this to beginning, it means you're making your first repayment right away, which most of the time doesn't make sense. If you need money, it doesn't make sense to give any of that money back immediately. That doesn't make sense at all. But there are some exceptions to that. For the most part, we're going to take exception when we talk about investing. If you invest money, most people, when they decide to invest, I think they will have the money and they will invest at least some right away. So that makes sense to make that the beginning. But it doesn't make sense to say like, oh, I'm going to invest. I'll do that at the end of the year and then like wait a whole like 11 months or something like that to make your first investment. If you have the money, you'll probably do that right at the beginning. So we make that the beginning. There are some loan situations where it makes sense as well. The most notable one would be like a car lease, right? If you're going into debt because it's like a car lease where you're actually taking physical property off the lot, you're definitely not going to be able to leave that lot without making some sort of payment first. They don't give you like 1 month for free on a lease. So that would be something where you would switch this mode to beginning because you do need to make your first lease payment right away. But for these, for our course, we're gonna just assume that all the loan repayments are made at the end, and we'll say all the investments are made at the beginning, just to give them a nice, one size fits all for each situation. Okay, so let's say we're gonna borrow $20,000. We don't know what the payment's gonna be. We do want to pay this off, so the future value is going to be 0. And the rest is now an interest rate. Let's say this is going to be monthly, so let's make it 9% compounded monthly. And we'll say $20,000. Let's give ourselves 10 years to do this. So 10 years times 12 months per year, that means it's a total of 120 periods. Okay, so we got a present value of 20,000. Future value is just always going to be 0 if it's a loan repayment. You don't want any debt. 9% interest rate for 10 years. So that's 120 periods compounded monthly. You press payment, and that means every month we would need to repay $253.35. So that you could take that payment amount and then start to do like an amortization table, because now you have the payment and you can go year by year or month by month and figure out what your repayment's going to be equal to. Okay. Once you kind of get this idea, using the TVM calculator goes pretty quickly overall. Okay, so we're going to switch and get into an investment next. So you can see a couple of different scenarios there. So we're going to switch to beginning because it's an investment. We're going to invest, the moment we decide we're going to do it, we're just going to go to the bank and start it up. So there's a couple of different scenarios here. This first one we'll say is that let's say we don't have any money to start with, and we're going to be making a regular payment. So we could maybe start with like an investment goal. If we knew we needed like $10,000 in 3 years, that means that we would need a future value of $10,000, and we would be asking, what's the payment we need to contribute in order to have that money in 3 years. That's one way we could look at this. Or we could come from the point of view and say, like, I have $150 in my budget monthly or biweekly that I can spare, and I want to do this for maybe 6 years or 20 years or whatever. Then you could figure out by the end, what is the future value of all these contributions. Those are the two different investment situations we're going to consider here. So let's continue on with this one. Let's say we have $150 and we're going to do this bi-weekly. So every paycheck or so, we're going to take away $150 and invest it. Let's say that the investment can be 4.5%, 4.5. And we're going to do this for 10 years. So biweekly is 26 times per year. 10 years is going to be 260 then, so times 10. So the 4.5%, 260 periods biweekly, only one blank now, and that is the future value. So this investment would then total up to be about $50,000 when we would take it out in 10 years. That's what those $150 contributions will work out. So each of those $150 payments, the earliest ones gain the most interest because they're in the account for the longest. And then each later payment gets a little bit less interest each time until you get to the end when you withdraw your money. Okay, so let's do one more like this. Let's say that, again, we have no money to start with. So with the loan repayments, we were always assuming the future value is zero. When we're starting an investment, we're basically pretending we don't have any money to start with. That you can still do this with a present value that isn't zero. But for most people, or for these simple questions, we're going to assume we don't have any starting money that we're working with. Okay, so let's say that we can spare $500 a month, and we don't know what the future value is going to be. Let's make the interest rate 7.2%, and this is going to be monthly, and let's say this is for 5 years. So that's going to be 5 years times 12 months per year, which is 60 months. And we filled in all the blanks except for future value, so we press FV. This investment would yield $36,000 or so in a return that we could withdraw. Okay, so again, I'm talking about this really ignoring the negative signs at this point. Technically, what I'm saying when I make that positive 500 is like I'm actually taking $500 and then paying it back later. The directions don't actually matter there. Technically, I should probably do it like a minus $500 so that the future value is positive. I'm paying out that $500 and getting back the $3,600. It doesn't change the numbers in these simple cases though, so you don't really need to worry about it that much. Okay, so we'll do one more example where we have a savings goal and we're trying to figure out what our payment is. This is a little bit more similar to like loan repayment, where the payment is kind of this magical number. So we'll reset the calculator again. Again, present value, we'll make sure to change that back to beginning. Present value is zero, we don't have any money. Let's say we wanted to save $12,000 for like a pretty nice used car. And let's say we wanted this in 3 years. And let's go back to biweekly. We'll make it like paycheck oriented. So let's say the interest rate is just a nice 5%. And we're going to say we want to save this in 3 years. So 26 times 26, not times 26, so 26 plus 26 plus 26. I think that's the 78 we did at an earlier question. So we need $12,000 in 3 years. We're going to do this bi-weekly with a contribution, and the interest rate we can get is 5% compounded bi-weekly. So we get into our last part here, the payment. If we put away $142 per paycheck, and we did that for 3 years, with that account earning interest, we would get our $12,000 that we can use for that vehicle. So again, then you can take that payment amount, put it into like an amortization table, and you can start to calculate the different rows and how that overall investment grows over time, each period. So we'll just do one more example about exactly the same as this one, and then that'll be it for this first video. Okay, so let's reset, change it back to beginning. Let's choose our time frame first this time. Let's make it not daily. Let's do quarterly. This is 4 times a year. So once a season or so, you're gonna put away some money. So we're starting with nothing. Let's aim for an amount of money, let's say $2,500, and let's give ourselves an interest rate of, let's say 7.9%. And how long do we want to have to save this $2,500 quarterly? Let's give ourselves 6 years this time. So 6 years every quarter. So that's going to be 6 times 4, which is 24 total periods. If I wanted to save $2,500 and I had an investment account, 7.9% per year, but compounded quarterly, I would need to put away, this is going to be a fairly small amount of money. That's only $80 per quarter, right? So every 3 months, it's because 3, 6, 9, 12. Yes, there's 12 months in a year, so every 3 months is a quarter. So every 3 months you put away $80 and you put that into an account, and that would get you the $2,500 in 6 years. So that's how you can navigate a TVM calculator. Get a little bit of practice with it, go through the practice questions posted for you, and you shouldn't have too much trouble catching on. But overall, it's a really useful tool in order to kind of figure out what you might be saving for. Again, especially if you're aiming for something like a down payment on a house, it does make sense that if you're doing that for several years, that you might want to get some interest on that to help you out as well, going a little bit beyond just the portioning out that you would do with a regular budget. Okay, so at this point, we'll sign off on this video, and if you have any questions, we'll see you in class later.